Welcome to this explainer. Today, we are tackling the absolute elephant in the room when it comes to AI agents, unpredictable behavior. Look, if you've ever felt like your AI agent is just a little too chaotic for mission-critical tasks, well, you are definitely in the right place. We're going to draw a hard, architectural line today between a fun weekend prototype and a robust, reliable enterprise system. And that brings us to the core thesis of this whole explainer. It's a really powerful idea. If you're relying purely on a generative model to navigate its own workflow, you don't actually have a safety boundary. What you have is a suggestion log. And let's be real, suggestion logs absolutely do not belong in charge of production systems. A true production state machine must have the hard-coded authority to say no. We really have to stop treating AI as this unconstrained creative engine and start treating it as a component within a strictly governed system. So, here's our blueprint for today. We're going to dismantle the illusion of AI safety, introduce the state machine architecture, define some strict trust boundaries, figure out exactly when to say no, and finally, we'll look at human-in-the-loop systems to make your agents truly production-ready. Let's get right into it. Kicking things off with Section 1, the illusion of AI safety. We really need to move beyond just tweaking prompts. Let's break this illusion right now. Just typing "be safe" or "follow the rules" into a system prompt? That is nowhere near enough to keep things secure in high-stakes environments. See, AI models are inherently probabilistic. Think of them like incredibly enthusiastic, super creative interns who might just confidently guess the totally wrong answer. If every single suggestion they make becomes an automatic action in your system, you are literally driving without brakes. Real safety requires a deterministic framework, a rigid manager that restricts that autonomy to predefined, genuinely safe transitions. Which leads us perfectly into Section 2, Enter the State Machine, where we talk about enforcing strict logic. To move beyond those fun toy applications, we have to introduce an architectural overseer, and that is the structured state machine. The crucial point here, and I really want to emphasize this, is intentionally limiting an agent's autonomy. Think about it. If you ask a raw agent to do some deep research, it might just get trapped in an endless, wildly expensive loop of searching and reading. But by forcing the agent to only decide on transitions within a predefined graph, you guarantee the process either moves forward or it halts safely. It's all about bringing predictability back to your workflow. This insurance claim architecture brilliantly illustrates this. Notice how the straightforward, low-risk claims just flow automatically from intake right to payout. But here's the kicker. The transitions between these states are guarded by specific deterministic rules. If a claim amount is, say, unusually high, or if the AI's confidence score drops below 85%, the system doesn't just take a guess. No way. It immediately routes it to pending human review. Or if validation flat out fails, it shifts to closed, rejected. The AI is operating strictly within these hard, uncrossable boundaries. And that brings us to Section 3, the pessimistic trust boundary. It's all about validating outputs. This is a completely foundational concept for secure AI engineering, the pessimistic trust boundary. Now, in AI engineering, pessimistic really just means zero trust. It is your absolute last line of defense. You simply have to assume that any LLM output could be flawed, malicious, or just a straight-up hallucination. Therefore, before any generated text translates into a real-world action, like querying a secure database or sending out a massive financial payout, it must cross this invisible line and be rigorously, deterministically validated by hard code. So how do we actually operationalize this boundary? Well, we essentially strip the LLM of its agency and enforce some really stringent defense mechanisms. First up, you absolutely need comprehensive output filtering to sanitize content. Next, you restrict the LLM's backend access using the principle of least privilege, meaning the model physically cannot execute unauthorized actions. And finally, for anything that's truly destructive or high risk, you mandate manual human validation. Moving on to Section 4, when to say no, and exactly where we should be positioning these boundaries. So where exactly in our architecture do we position these boundaries so the system can confidently say no? Well, it needs to happen at 4 distinct stages. First, pre-model checks. These reject invalid queries before the LLM even spins up, which saves you compute costs and blocks prompt injections right out of the gate. Then, post-model checks verify the generated response against your safety guidelines. After that, routing stage checks ensure queries only ever trigger authorized branches. And finally, tool-level checks block unsafe actions right at the point of execution. Notice how in this pipeline, generation is strictly downstream of policy. Every single request is processed top-down. A sentinel screens for crisis triggers first. If a risk is identified, the system immediately diverts to a predefined crisis protocol, completely bypassing the AI's generative reasoning engine. Safety here isn't just a polite prompt asking the AI for good behavior, it is a hard, deterministic circuit breaker. And this concept scales all the way up to physical systems, too. Think about robotics for a second. This is the ultimate no. An independent safety gate intercepts and physically rejects actions before they hit the real world. The LLM might propose a movement, sure, but if it violates velocity constraints or physical bounds, that safety gate blocks it before it ever reaches the actuator. The system's ability to say no is physically hardwired, ensuring the robot doesn't accidentally launch itself through a brick wall just because the AI thought it was a good idea. Which leads us to Section 5, Human-in-the-Loop Escalation. Let's talk about engineering oversight. Because we can't engineer away all uncertainty, we have to engineer how we handle it. When an AI agent evaluates a scenario and detects high risk or low confidence, the workflow shouldn't just take a wild guess. It needs to pause at a safe, reversible checkpoint. This is the whole concept of interruptibility, stopping the agent without corrupting the work in progress and allowing a human to explicitly step in to either approve or reject the action. This bit of code effectively acts as a safety valve for high-stakes business systems. Notice step 2.5 in this e-commerce workflow. If the LLM risk analyst flags an order as medium or high risk, the automation loop breaks. It explicitly requests a human input of approve or reject. It prints a warning, halts the automated chain, and just waits. Let me tell you, gracefully ceding control to a human operator like this is absolutely essential for any production deployment. Let's tie all of this together in Section 6, Production-Ready Agentic Systems. In highly regulated fields, think medicine or finance, uncertainty must be treated as an actionable control signal. Far too often, a language model will generate this fluent, totally plausible-sounding explanation that actually masks its own uncertainty. That's a really dangerous hallucination. In a true production state machine, low confidence shouldn't result in the model trying to sweet talk or persuade the user that it knows what it's doing. It must automatically default to escalation, triggering a state transition directly to a human supervisor. Deploying at scale requires these foundational elements to balance the sheer speed of automation with strict absolute governance. 1, you need reversible checkpoints for safe intervention. 2, you need state graph routing, so every single decision leaves a traceable audit trail for compliance. 3, you must treat compliance and safety as first-class layers in your code, not just afterthoughts bolted on at the end. And finally, continuous observability is non-negotiable. You have to monitor inference latency, error rates, and overall system health in real time. So I'll leave you with this provocative thought to chew on as you design your next AI architecture. Is your agentic system a resilient state machine, or is it really just a sophisticated suggestion log waiting to break? Are you building true safety boundaries where your system can confidently say no, or are you just crossing your fingers and hoping your suggestion log doesn't hallucinate when it matters most? Thank you so much for joining me on this explainer, and I really hope this helps you build safer, more reliable AI systems moving forward.